Today we will discuss about genetic algorithm. Genetic algorithms are mainly used for optimization problems. Optimization is defined as the process of finding maximum or minimum value for a particular problem. This genetic algorithm is belonging to a category of algorithms called as population based algorithms, population based search algorithms, or you can call it as it is belonging to evolutionary computation algorithms, evolutionary computation algorithms. In this genetic algorithm, we will generate a set of candidate solutions. We will generate a set of candidate solutions which we call as a population, which we will call as a population for finding optimum values, for finding optimum values, optimum values. That means for each iteration, instead of generating one candidate solution, we will generate a set of candidate solutions for finding optimum solutions, and hence the name is given as population based search algorithms. So diagrammatically, in this genetic algorithm, we will start with some initial population. Population means set of solutions. We will start with some initial random solutions. All are random solutions, initial solutions. And then for this initial population, this is initial population. To this initial population, we will apply operators like crossover or mutation. We will see what is those operators. These two operators are applied on initial population to generate a new set of population, new population, which consists of a set of candidate solutions, and it is believed that in this new population, all the solutions in this new population, all the solutions are better than the previous solutions in the initial population, are better than the previous solution in the old population. So that means for every iteration you will perform or generate new population from old population with the help of standard operators like crossover and mutation. These two steps are repeated until you get a good population. Good population means until we satisfy the optimization criteria, we have to generate new population. So that means you have to generate new population until the termination criteria is reached. Until the termination criteria is reached. So termination criteria, it can be maximum number of iterations, or good fitting values, fitness values. Okay, so you need to repeat those 2 steps until your termination criteria is reached. So if you see this process is exactly similar to our nature process, genetic process, where the new generation is always better than the old generation, and the new generation is able to survive or adapt to the new conditions, and hence the name genetic algorithms are given. Okay, so we are going to use some terminology in biology. So, but the fundamental concepts in genetic algorithm is, this is the fundamental concepts. So, let us see what is happening. Let us write the steps. What are the main steps that are followed in genetic algorithm? We will write shortly as GA. The first step is you need to define the fitness function. Define the fitness function. Define the fitness function. You can call it as a F, and you can define some control parameters like maximum number of iterations. Second step, the main step is you have to initialize the population. So in the first step, you can define the population size. It can be n also. So I am writing the steps. After that, a detailed explanation is given. Third step is, after defining the population, what you have to do means, you need to select the parents from the population and then generate new population. So what I will do means, I will directly write generate new population with the help of crossover, mutation operators. After generating the new population, we will perform the evaluate the new population, and then you have to compare with old population. You have to compare the new population with old population, with respect to individual solution wise manner, and then select the best solution, and store in the new population. Sometimes when you are applying the crossover mutation operators, you may get some bad solutions also, or you can say as a weak solutions. So you cannot pass the weak solutions into the next iteration. So only the best solution has to be stored in the new solution, and then you need to repeat the steps. Okay, repeat the steps. That means you can go to you have to repeat the steps. That means you can say as a go to step 3. In the step 3, you can check whether termination criteria is reached or not. Terminate condition is reached or not. Is reached or not. If termination criteria is not reached, you need to generate a new population with the help of crossover and mutation, and then store the best solution and forward to the new population, and again you need to check the termination condition, and you have to repeat these 3, 4, 5, 6 steps repeatedly. If termination criteria is reached, you can come out of the loop. You can come out of the loop and you can choose any one solution as a best solution, display the good population, and what you have to do means choose any one solution, choose the best solution as a best solution in the population as the optimum solution. Optimum solution. These are the steps we will follow to find out optimum solution in genetic algorithm. So once again I will tell. So you need to find out the fitness function and randomly generate the population. So you need to repeat the steps 4, 5, 6 to generate new population, and then you need to check the conditions. Once the termination criteria is reached, you can output the final population and then choose the best solution as the optimum solution. These are the steps that are typically followed in the genetic algorithm. So if you observe in this, we have come across some new terms called as crossover, mutation. You can see this. So let us see these two terms. What are how it look like and what it is performed in crossover and mutation. Let us define. Okay. So let us define what is crossover. Crossover. We already told you we are discussing the genetic algorithm, binary genetic algorithm. That means we are discussing a binary representation of features in genetic algorithm. In this genetic algorithm, we will represent each solution in binary form. Then only we can apply the crossover operator. So let us see. This crossover operator, it resembles the biological crossing over, and we will recombine the two different parts of the two parents. That means this crossover operator is applied on two features. Say for example, let the feature is something like this, P1. We already told you we are discussing the binary form of genetic algorithm. Let us take the solutions in binary form. For performing crossover, you have to take two solutions. So it can be applied on two operands. It can be applied on two solutions. So let us take two solutions represented as P1 and P2. Let the P1 be 1 1 0 1 0 1 1 1 0 1 0 0. This is one solution. Let us assume you take another solution P2. Let it be 0 1 0 1 1 1 0 1 0 1 0 0 1 0. For performing crossover operator, you need to select two solutions, which we will call it as a parent solution. What we will do means we will randomly bisect the solution into two halves. You take any bit position and you randomly bisect. Let us say you randomly select 1, 2, 3, 4th position. So at this 4th position, let us divide into two halves. So let us divide the solution at random location, at random position. It can be 5th position. In this case, for our understanding, I am bisecting at random position 4. So 1, 2, 3, 4. And similarly for P2 also you need to divide the solution into at position 4. So 1, 2, 3, 4. Same. Once you perform the division operator, the next thing is you need to perform the crossover. After performing the crossover, you will get two outputs, or you can call it as a two childs C1, C2. P1, P2 means parent 1, parent 2, and you will get two outputs. That means two childs. So what you will do means you take the first half of the first parent and second half of the second parent. You merge these two to get first child 1 1 0 1, and again you take the second half of the second parent 1 1 0 1 0 1 0 0 1 0. Similarly, for getting the second child, you take the first half of the second parent and first half of the second parent and second half of the first parent. So 0 1 0 1. After that you take the second half of the first parent, that means 0 1 1 0 0 1 0 0 0 0 to get two child solutions. Okay, so this is how crossover operation is performed in genetic algorithm, and it will lead to two child solutions. It is simply dividing the solution and then performing the swap operation. Okay, so I think it is clear. So you need to understand that for performing crossover operator, you need to have two parent solutions, and the output will be, you will get two child solutions. Okay. Similarly, let us define another concept called as mutation, because these two operators are needed for writing the genetic algorithm. What is mutation? This mutation operator, it needs only one parent. you need only one parent. Unlike crossover operator, in mutation you need only one parent P1. So, in mutation we perform random flipping of bits, random flipping of bit values. That means if you are having any bit value as 1 means you have to convert into 0. If you are having any bit value as 0, you need to convert into 1. So therefore, you have to first randomly select one bit position and then applying the mutation, applying the mutation. Mutation means simply flipping the values. If the bit value is 1 means you convert into 0. If the bit value is 0 means you convert into 0. So let us take one example. Say for example, if you are having a single parent 0 1 0 1 1 0 1 1 0 0 1 1. So if you are having a parent solution like this, parent P1, you want to apply mutation operator, you randomly select one bit position. Say for example, you randomly selected bit 8. So at bit 8 location, the value has to be flipped. Let us find out that location 8. 1 2 3 4 5 6 7 8. So therefore this position, what is the value for this position? It is 1. So 0 1 0 1 1 0 1. Now you have to flip it to 0, and remaining bit positions you should not alter to get new child solution. Okay. So this is how we will perform the mutation operation. You will perform the mutation operation. Mutation operation. I hope it is understood. In some algorithms, we are also having another concept called as a elitism. Elitism. E-L-I-T-I-S-M. Elitism. So in elitism, what we will do means, say for example, in your population P1, you are having 5 solutions. 1, 2, 3, 4, 5. This is solution S1, S2, S3, S4, S5. Generally, this is your old population. Okay. Old population. Old P. So to generate a new population, we will apply mutation and crossover. In this elitism concept, what we will do means, we will select, if the elitism size is 2 means, say for example, if you define the elitism parameter, elite parameter as 2 means, you take the two best solutions. Say for example, let us assume S1 and S3 are the best solutions. So in elitism, what we will do is, this S1 and S3, they are simply transferred to the next generation. This is the next generation, new population. In the new population, instead of going through crossover and mutation, we will directly pass S1, S3 to the next population, and then to generate a new population, what are the remaining populations are there? Remaining solutions S2 and S4 and S5. So with this S2, S4, S5, we will apply the mutation. We will apply the mutation, crossover and mutation to fill up the new population. That means the two best solutions are directly transferred to the new populations without applying any standard operations, crossover or mutation. Now, to fill up the remaining solutions, what we will do is, we will perform S2, S4 or S2, S5 or S4, S5 to fill up the new solutions. Okay, S24, S25 and S45 to generate new populations. This is called as elite populations, elitism. So that is the concept behind this elitism. So generally these three operators we will commonly apply in genetic algorithm in producing new population for every iteration. Okay. So once we understood all these concepts, let us write the algorithm for this. We have already written the main steps. Let us write more clearly. Okay. Let us write the genetic algorithm. So let us write clearly. First thing is define the inputs. So you have to define the fitness function and then control list parameters. Okay. Generally, control list parameters means it will include the maximum number of iterations. The second step is, we have already seen the random initialization of the population. So you take some random algorithm with the help of some distribution function, you will generate a population, initial population with the help of, in this control list parameters, you can define maximum number of iterations and then the population size n, that means the number of solutions in each population, and the function PDF functions required for initialization, PDF functions, or you can call it as a uniform distribution function. You can take uniform distribution function. All this you have to define in the control list parameters. Okay, and then the third step is find out the population size. You can call it as a NP, which is already defined in the control list parameters. Get population size and the third step is population size, and then you have to define the elite size, how many number of elites should be extracted, how many number of elites should be extracted from each generation. So that parameter is also you can define in the control list. Elite population E. Get elitism of C. And the next is, let us define a loop variable, because I already told you, you have to run this algorithm for n number of times up to maximum number of times. So for algorithm purpose, we will define a loop variable. Now we will define a stopping criteria. Let us assume our stopping criteria is maximum number of iterations. I is less than max iterations. If this condition is satisfied, let us run the algorithm. So first step is, we will evaluate all the solutions in the current population. This is called evaluate evaluation of current population. And then the next step is, you need to select the best solutions for elitism. For selecting the elites, you need to apply some function. So what you have to do means, you select the elites. That is the next step. Let us denote it as PE. Okay. So with the help of best function and with the help of evaluated values, with the help of E parameter, what we will do means, we will find the elites. In the 8th step, we will extract the elites from the current population. Okay. So those elites did not participate in crossover or mutation operators. They can directly transfer to the next population. That is why we are finding the elites. Okay. Next thing is, you need to apply the crossover and mutation operation to the remaining solutions in the population. So for that, what we will do is, you have to select the parents, and then you have to apply the operators. So next step is, select the parents. Select, let us define one function. So you are having a current population and then evaluated values, and you need to select the leftover solutions. That means total solution minus elite solution. So this step, that is the 9th step, what we will do is, we will select the parents. Randomly. So here we will use the probability. Basing on the probability only, we will select the parents. After selecting the parents, you need to generate the children with the help of crossover operator. For this crossover operator, you have to pass the parents and then some C control parameters. I already told you, in the control list parameters, we have already defined the uniform distribution function. Okay. So once you define the uniform distribution, you randomly select certain bit position, okay, and then perform the crossover. So that is a reason why you need to define the distribution function. So let us go to the 11th step. After crossover is happened, you take the mutation operation. For this mutation operation also, function you send the parents, and then since we have already generated the children in the previous step, you can write children here. You can define the mutation, and then you can pass the control list parameter. So we already told you in mutation also you need to randomly select a bit position and then flip the values. So for that reason also you need to pass the control list parameter. So children, and the next step is, so we performed the mutation operation also. So after that you need to merge these children with the elites. So we already got elite, and then you need to merge with the children produced after mutation and crossover operator, and label it as a P new. P, that is a new population. So this is your new population. New population. So which is generated with the help of sum of elites plus the children. So here the logic is elites are directly passed on to the next generation. So that is the logic here. In the 30th step, you update the loop variable. I is equal to, this is just a loop variable. And then in the 14th step, you can end the process, end the while loop. Finally, after n number of iterations, you will get the optimum population or strong population. So finally at 15th step you will get P. This P means, here you need to understand it is a good population or last population. But we want only the optimum value, best optimum value. So what you have to do is, for finding the optimum solution, so you have to select the best from the, let us term as a P last population, from the last population, and then you can output. Okay, this is how we will perform optimization using genetic algorithm. So let us once again, for this algorithm the inputs are, F means fitness function. You can write here F means fitness function, and then perform the second step is random initialization of initial population, and then third step is define the population size, fourth step is define the elite population number, fifth step is loop size, sixth step is termination criteria condition, and 7th step is evaluate the current population, and then 8th step is choosing the elites. If you are performing maximization, you need to select the solutions which are having maximum fitness value. Okay, so those are called elites. And then 9th step is selecting the parents. 10th step is obtaining the children from crossover. 11th step is again obtaining the children from mutation operation, and the 12th step is merging the elite with the children produced. And the above steps are repeated until you can see you reach the maximum number of iterations, and you will get the last population. So out of the last population, to display the output, you need to select the best solution in the last population, and you have to display the result. In this way, you will find the optimum values in the genetic algorithm. Here the basic assumption is each population is better than the previous population. Okay, so that's how the algorithm will works. If you see what is happening means each solution or each population is better than the old population. So that's why the name is given as evolutionary algorithm. That means a new population is evoluted from the old population. Okay, so you need to understand this. So let us after understanding this, let us see one example about how the algorithm will work. Actually, we have discussed the binary version of the genetic algorithm. Okay, so that means so whenever a problem has to be solved means you need to convert the solution into binary form, and then you have to solve binary form and then apply the crossover and mutation operations. So let us define one, take one example how it works. So let us example, let us take a function f of x as minus x square by 10 plus 3x. So you need to find the maximum value. So x max. Okay, in between 0 to 31. So let us suppose this is a maximization problem where you need to find the x star such that f of x is maximum. Let us see. Okay, your x can be any value between 0 to 31. So if you observe it, the x value ranges from 0 to 31. I already told you we are discussing the binary representation of the solution. So x can take the maximum values up to 31. Therefore, for representing the solution, the feature length or the length of the solution is 5 bits. So 5 bits are enough to represent the values up to 31. Okay, so because in 5 bits the length is, the maximum value is 32. That is the reason. Okay, so x can have value between 0000002 up to x31 means 1111 this is 32. Okay, x1 means this one. So this is how the solution is represented, and the length we have fixed is 5 bits. Okay, so let us see how we will solve this. So during the first iteration we have to initialize. Okay, this is the starting, and let us define the population size as 10. The population size as 10. So during the first iteration, this is the first iteration. So let us define the chromosome number, and then initial population, and then the X value, fitness value, f of x, and then the selection probability. Let us define one by one. So we already discussed the initial population is generated randomly. Let us suppose we got 0, 1, 0, 1, 1 as the first randomly generated solution, and the corresponding x value. Let us first generate all the population. I already told you the population size is 10. Let us suppose. So first we will generate some initial population 1, 1, 0, 1, 0, and we generate another population with some distribution function 0, 0, 0, 1, 0, and the fourth one is 0, 1, 1, 0, and the fifth one again you call your uniform distribution function, and it will give you 0, 1, 0, 0. It can be different, so each time it will be different. 1, 1, 1, 1, 0, and then 1, 0, 1, 1, 0, and then let us suppose 8 is 0, 1, 0, 0, 1, 9th one is 0, 0, 1, 1. Let us suppose 10th solution is 1, 0, 0, 1. This is 7th solution, and its corresponding x value is 11, 26. So I am going to show you how the algorithm operates to, and the corresponding the fitness value. Just you need to convert the binary into the decimal form. Okay, 0, 1110 means its corresponding value is 14. 0, 1100 means its corresponding decimal value is 12. So you need to multiply each position value by its weight, and then you have to sum it up. Okay, so that's what we have done here. So 30, and the corresponding value is decimal value is 22. For 8th solution 0, 1, 1, 0, 1 is it is 9, and this is 3, and then 17. Now calculate the fitness value. Okay, let us calculate the fitness value. So fitness value you will get with the help of substituting the x value in this function. Substituting the x value in this function. This is the function that is given in the example, minus x square by 10 plus 3x. So if you put 11 inside this function, you will get the fitness value. Likewise, you substitute all the values and you will get the fitness value. So since I have already pre-computed it, so I am writing directly 20.9, 10.4. If you substitute 2 in the above equation, you will get 5.6 and 22.4, and then 21.6, 21, this is x30, you will get 0, and then 17.6 you will get, if you substitute 9 in the above equation, you will get 18.9, 8.1, 22.1. Now the next thing is selection probability. So after calculating the fitness value, we have already discussed in the algorithm. In the ninth step, if you see the ninth step, you need to select the parents based on some probability. You need to select the parents randomly. For those parents, you need to perform crossover and mutation. So how to select the parents means, here we are going to use selection probability, selecting the parents based on probability. So this selection probability is calculated with the help of, I will write here the formula. It's very simple. Selection probability is of a particular solution xi. For a solution xi is given as f of xi by sum of f of xi, where I is running to 1 to n. So what you have to do means, so you calculate the sum. Okay, here what is the sum of the fitness value? So it is clearly 147.6. So what you will do means, to calculate the selection probability, of first solution 11, so you perform 20.9 by, what is the sum of fitness value of all solutions? 147.6. So if you substitute 147.6, you will get something like 0.14. Similarly, the selection probability for x is equal to 26 is 10.4 by 147.6. So you will get something like 0.07. Similarly, you need to calculate the selection probability for all the solutions. So here, what my idea is to explain how the operations are performed in the genetic algorithm, how parents are selected, how initial population is generated, how fitness value is calculated, how selection probabilities are calculated for each solution, all are explained. So similarly for solution 2, the selection probability is 5.6 by 147.6. So maybe you will get some 0.3. So I am writing directly. For 22.4, the selection probability is 0.15, and then 0.14. The selection probability for 30 is 0. The selection probability of 17.6 is 0.11. Similarly for 0.12. Similarly for selection probability for solution 3 is 0.05. Solution probability is 0.14. So you need to calculate the selection probability for all the solutions. The main reason for finding this is for selecting the parents. So this is what is happening in the first iteration. So let us move to the next. After calculating the selection probability, it is time for reproduction. So to generate new population with the help of reproduction operators. Actually, we will call both mutation and crossover as a reproduction operators. So let us see how we will generate new population with the help of reproduction operators. So here we will use crossover and mutation. So let us write let me change the color. So for in this example, we are not taking the elitism concept directly. We will take we will perform crossover and mutation. If you want, you can take the elitism concept also. So I think so. Can you tell me what is the maximum, since it is a maximization problem, what is the maximum value here? Can you tell me? 22.4 is the maximum value, and after that you will get 21.6. So these two are the maximum fitness value. So you can consider these two as elites. Okay, elites also you can consider. So but for our, you can directly add to the next generation. So but here in our example we are not doing that. You can perform as a exercise. As of now, I want to tell you the crossover and mutation operators. So next thing is you have to generate the new population. This is mating pairs. So randomly you select two features or two solutions as parents based on the selection probability. So we have got already the probability here. Based on the probability, we have to select the parents. Okay. So let us suppose 5 and 2 are selected. This is one pair of parent, and you take, again you sample it based on the selection probability. Let us assume you got 4 and 8 as second pair, and 9 and 2 as third pair, and 7 and 4 as fourth pair. 1, 2, 3, 4. Fifth pair is 10 and 8. So total 5 pairs we got. For this pair, let us suppose write the binary value representation 0, 1, 1, 0, 0. So these chromosomes numbers are selected purely based on the selection probability. 1, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, and 9 is 0, 0, 9, 0, 0, 1, 1. So just we are writing, we are selecting the ninth feature and second feature. What is the ninth feature? 0, 0, 1, 1, and 2 is 1, 1, 0, 1, 0. So that's what we are doing here. Second 2 means 1, 1, 0, 1, 0, and again 7 means you can see the previous table. You will get the binary value 1, 0, 1, 1, 0, and 0, 1, 1, 1, 0. 10th feature means 1, 0, 0, 1, and 0. 8th feature means 0, 1, 0, 0, 1. So all the values are we got from the old table. Okay. Let us see. So first we will apply the crossover. For applying the crossover, you need two parents. Two parents are selected. You need to perform, I will write in red color. What we will do is, you randomly select one bit position. At that bit position, you have to divide the parents into two halves. So let us take, we divide it at second position. At that second position we have divided. Let us make the swapping. So if you perform the swapping, you will get like this: 0 1 0 1 0 and 1 1 1 0 0. So you can see this. So let us suppose, for example, you take another pair 4 and 8. For this 4 and 8 pair, let us divide randomly. So let us, you can divide by using uniform distribution. After dividing it, let us merge these two off, and 0 triple 1 and 1 will get. If you merge these two, you will get something like 0 1 0 0 and 0. I think you are getting my point. And then you randomly select one bit position. Let us take same thing: 0 0 0 1 0 and 1 1 0 1 1. And again you can select any bit position. 1 0. For a change, what we will do is, there is no crossover, or you can divide here also, not a problem. 1 0 1 1 0 and 0 1 1 1 0. So there is no difference actually. Let us divide at third position, at third bit position: 1 0 0 0 0 1. So I have written extra one: 0 1 0 0 1. So let us see what is happening. After crossover, you can apply mutation. You can apply the mutation operation also. You can apply the mutation. So for each solution, you randomly select one bit position and you convert 1 into 0. Okay, so for time constraints, you can take any one bit position and you can change it. And say for example, this position 0 1 0 1 1. So 0 is changed to 1. Let us take for this solution, you change here 1 1 1 1 0. You can see mutation operation, it takes only one parent only. Let us change here. You take one position randomly and then you change it. You change here 0 1 0 0 1. Let us change the second position: 0 1 0 1 0. Let us take the first position. Let us take the last position: 1 0 1 1 1. Let us take the last position again: 1 1 1 1. And again, so in this way, let us take the third position: 1 0 1 0 1, and then let us take the again first position: 1 1 0 0 1. So with this way, we got a new solution. This is your new population. So with this I want to tell you that how new populations are created with the help of old population. So this is a simple example. I have just written example for one iteration. This type of executions operations are performed over n number of iterations to get last population. Out of this last population, you have to select any one position as a best solution. Whichever is having the best fitness value, let us suppose this is the best fitness value, means this is called as a optimum solution. Okay students. So I want to illustrate how the genetic algorithm will work, how the genetic algorithm solutions are generated for each iteration. Okay, I hope everybody understood all these concepts. Thank you, students.